Welcome to Lesson 9, Solving Using the Quadratic Formula, where now that you've seen the quadratic formula and got a chance to practice using it, we're going to see it in a few more examples and compare it to some of the other methods we've seen to solve quadratics. So our learning goal today is to use the quadratic formula to solve quadratic equations and determine the real roots of quadratic functions in real life situations. So we're starting with our first example where we're given the function f of x is equal to 4x squared minus 7x minus 15. So we're going to apply the quadratic formula to get negative b squared negative 4ac. And we will divide by 2a. So just in case you forgot, we have this as A. We have this one as, let's do this as B. And we'll do our last one as C here. And the quadratic formula tells us x is equal to negative b plus or minus b squared minus 4ac over 2a. So all I've done is substitute those values in, keeping in mind that those negatives also belong to the coefficient, so making sure I've included those. And now we are going to begin our calculation. So we get 7 here, and inside the bracket you should get 289 divided by 8. And now we are going to split this into x1. And here, I recognize this, but you may use a calculator for this, but this is the square root of 17, so I'll just write it as 17 over 8. And this will simplify to 24 over 8, or 3. And for x2, we're going to write it the same, but with the negative now. And here we get negative 10 over 8, or simplify to negative 5 over 4. And so those are my two roots, or the solutions to my to the equation where f of x is equal to 0. So now, could we have solved this in a different way? And if you recall what we've been doing so far before we saw the quadratic formula, we're going to try using factoring methods to solve this. So let me just rewrite my function one more time. We have f of x equals 4x squared minus 7x minus 15. So first, this is a trinomial, so it's not a difference of squares. So I'm going to check if it's a perfect square. The first term, 4x squared, that one could be, because 4 is a perfect square and so is x squared, but my negative 15 term is not a perfect square. So this is not a perfect square trinomial either. So we're going to try factoring by decomposition. And already I knew there were no greatest common factors here for 7 and 15, nothing I can factor out. So I want to find two numbers where their product is going to be negative 60 and their sum is going to be negative 7. So take a moment, try this, and I'll come back to give you the answers. So you should have found that your answers are, the two numbers are negative 12 and 5, and this will also give us that negative 7 as their sum. And so we will write this in decomposition method, so negative 12x plus 5x minus 15. And factoring out a 4x here, we are left with x minus 3. And a 5 from here, we're also left with x minus 3. And taking that term out. And so remember, this is equal to 0. That's the equation we were trying to solve. So now, using the zero product property, I will let this equal 0 so that for x is -5 and x is -5 over 4. And here, x minus 3 equal to 0 means that x has to be 3. And we check from our solutions above, and they do match, which is what we were expecting. So you can apply either method. As mentioned last time, quadratic formula will give you the answer right away, but if you factor it, it also helps, especially when we are looking at the graph. So we'll see that shortly. So in this example now, we're going to be solving the same question, which is of when will the coin hit the water, but using different methods. So the problem we're told is that a quarter is thrown from a bridge 15 meters above a pool of water. The height of the quarter above the water at time t is given by the function. H of t is equal to -5t squared plus 10t plus 15. So time here is in seconds and our height is in meters. And we're asked when will the coin hit the water. So first I'm going to try a table of value. And I've already filled out the values that you need there, but we would get 20, oh, sorry, 15, 20, also 15, and then 0. So from the table of values, I already have my answer. So when will the coin hit the water is pretty much when the height is at 0 meters. So here I see that when the time is 3 seconds, my height is 0. So uh, at time 3 seconds is when the coin will hit the water. That being said, I gave you the input values here. You did not have those. So having to come up with those input values is not always as clear, and you have to do a lot of trial and error. So that's not always the best choice, but it could sometimes work. Next, we would be graphing it. So graphing is more if you use a graphing tool and just input the equation, and we see what kind of graph we get. So let's try that here. So I'm just going to write -5. Again, remember Desmos does not have t, so I will be using x for now, but I will interpret it as t. And so let me just expand this a little for us. And so looking at the graph here, I can see that it matches exactly my table of values. So you can either do this or if you had plotted the points from the table of values. But again, that's something that requires 2 steps for you to do the table of values and do the graphing. So just looking at the graph, we would be looking at where the graph is intersecting with the x-axis, and we see that it's at point 3. So that is when the coin will hit the water according to the graph. Next, we are going to try factoring. So here, I already see -5, 10, and 15 all have that -5 in common. So I'm going to factor that out so that I have a equal to 1. 2t and 3. Okay. So here, I have a trinomial. It is not a perfect square, so I'm doing decomposition. So I want something, 2 numbers where their product is -3 and their sum is -3. 2. And because 3 is a prime number, the only 2 values would be 3 and 1, and that actually works. -3 plus 1 will give us that -2. So we have t minus 3 and t plus 1 because -3 times 1 is -3 and -3 plus 1 is -2. And so now from here, I see that when t is 3 or when t is -1, we have this equal to 0. That being said, we cannot have time as a negative. So time has to be greater than or equal to 0. So this solution does not work. Therefore, t is inadmissible. So again, that's our word for when the solution does not fit in the real world situation. And finally, we're going to try the quadratic formula. So here we are going to have t. So again, um, the quadratic formula is used with x, but here our variable is t, so we're going to use it as t. So um, I'm just going to rewrite. Let's just write a as -5, b is 10, and c is 15, just so I don't make any errors there. So -b plus or minus b squared minus 4ac over 2a. And so from here we get -10. Here we'll get 400 over -10. And now we can simplify this. So let me just simplify. T1 is going to be -10 plus 20 over -10, which is -1, and T2 is going to be the subtraction, so 3 seconds. But again, this one is inadmissible. So we've now seen 4 different ways to answer this question. So I'll let you reflect on which method you think is the best, which method makes most sense to you, and which one you might have chosen to solve this question. So looking at this function here, it's numbers that I don't want to tackle factoring. So I'm just going to write the quadratic formula right away and work with that. That being said, though, I hope you've noticed my function looks a little different. I have x squared here, and the first term is -63, which is my constant term. So I'm going to rewrite this as -14x squared plus 133x minus 63. And so now I have a is -14, b is 133, and c is -63. So please do not make this error if you have already. A, B, and C are not based on the order of the terms. A is specifically the coefficient of x squared, B is the coefficient of the x term, and C is your constant term. So now that I have my variables, I'm going to use the quadratic formula. So x is equal to -b plus or minus b squared minus 4ac. And mixing up A and C, you won't really notice the difference there until you get to the bottom part, the denominator, where then we have only A. So if you had made an error and wrote C and used the first term as A, you would have got -63 here, which would have given you a different value. So now, solving this through, we get and this would be over -28. So now, x1 is, and using a calculator, this is 119 over -28. And this simplifies to 14 over 28, or 2. And x2 would have been 19 over 28. This would have given us 252 over 8, or 9. And so when will the company break even? was when P of X is equal to 0. So we found that the solution to that is x1 is 2 and x2 as 9. So going back to our problem so we can interpret the results, the X is the number of products sold in thousands. So X1 being 2 means 2,000 and X2 being 9 mean 9,000. So if they sell 2,000 or if they sell 9,000 products, they will break even. So they will not be making any profit, but their revenue and their costs will be the same. So um, their profit will be 0. That being said, similar to the question we've seen before, if you sell anything between 2,000 to 9,000, you will have a positive profit here. So here you're given a question now of why might selling more than 9,000 not be profitable? So you would think that if at 9,000 they break even, then anything they sell more than that, they would be making profit from it, right? However, it could be that based on their facilities or based on the material they have, creating more than 9,000, for example, may break a machine, and the cost of that will be so much more that they will actually go into negative profit, and so their cost will actually be more. So when businesses are considering their profit, they do have to analyze trends in their profit to see make decisions about the cost, their price of their products, and other factors within their business. So here we are also given the graph, so we can just analyze those same results. So we saw that, oh, my bad. This should have been 1/2. So then um, 1/2 as 1,000 would be 500. So that's why we get that zero point 0.5 here. So 500 products. And then the 9,000 stays the same. The reason for this being 500 is because it's half, like X is half, or yeah, X is half, and X is in thousands, so half of 1,000 is 500. And let's look at our last problem for this lesson, where we are now given a point of intersection problem, but now that we have the quadratic formula, we're going to try it with the quadratic formula. So here we're given two functions, y1 and y2, and we want to find where y1 is equal to y2. So where 3x squared minus 4x minus 9 is equal to 2x. So to get the quadratic formula, to be able to apply it, we need an equation of the form ax squared plus bx plus c equals 0. But I don't have that yet. So I need to move 2x over to get that equality to 0. And doing so gives me negative 6x minus 9. So now here, as always, there's different ways to solve it. You might already see that I can write this way. And now that I've factored out the greatest common factor, I have a trinomial. And this trinomial may be familiar to you. That function is pretty much the same as the one we did here of t squared minus 2t minus 3. But now we have that in x. So same solution would apply here. So we would get um, x is equal to negative over 2a. This would give us 2. And here x1 would be equal to 2 plus 4 over 2, or 3. And x2 would be equal to 2 minus 4. or -1. And in this case, both the solutions will work because we are no longer working with time as our variable. We're just working with x for two functions that are defined over all x. So here we would just say that their point of intersection, so the their POI, point of intersection, occurs at x equals -1 and 3. And that would be your solution there. Oh, actually no, because it says determine the point of intersection. So, um, the point of intersection does occur at that x value, but we want to find the actual point. So we have to plug it back into one of the equations substituted to get the output value. And looking at these two functions, I hope you see that 2x is the easier function to use. So let me just move this down. We're going to have for this x, and for this one, we have, and so their point of intersection would be at 3, 6, or at -1, -2. And you can try plotting both of these points on Desmos and see that they do intersect at these 2 points. So for your practice problem today, you have similar to what we've done, just some practice with quadratic formula and a word problem. So please make sure you're comfortable using the quadratic formula at this point. And if you have any questions, don't hesitate to send me an email, and I'll see you all next class.